In this video we're going to be looking at some advanced trigonometry. In the previous examples, all trigonometry we did had a right angle triangle in order for it to work. This one doesn't. This is called the sine rule, and we're going to be using the sine rule to try and find missing sides in a non-right angle triangle. So we're going to start off by labelling this triangle. If I take all three of the angles in turn, and if I was to call them A, B and C, the position of these angles tells me what the side opposite them is called. So for example, the side opposite angle A is called side A, the side opposite angle B is called side B, and the side opposite angle C is called side C. Notice the difference between the angles and the sides. Angles we use a capital A for, the sides we use a lowercase a for. Now the sine rule itself comes in two different formats. Both are displayed on the screen now. We're going to be using this version of the formula. This version is important when we're finding missing sides because it has the sides on top in the fraction. A, B and C are in the numerator line of this fraction. Let's have a look at an example. In this example I'm going to start off by labelling up my triangle correctly. So this side here, let's call it angle A, and that means that the 7 cm side is A. This angle, 43 degrees, let's call it B, and that means that this X up here would be B. Now we're not actually interested in either this angle or this side, which I would have labelled C. So I'm going to leave those out of my calculation entirely, and I'm going to set up the problem using the sine rule. I know that the sine rule looks like this. A over sine A equals B over sine B. When I fill in the values from this particular example, I'm going to get 7 over sine 65 is equal to X over sine 43. Now the reason why we keep the missing value on the numerator line is it makes this calculation much easier to do. From here I'm going to multiply both sides by sine 43, meaning that 7 sine 43 divided by sine 65 will give me the value of X. When I type this into my calculator, I'm going to get a final solution of 5.3 centimeters for my missing side length. This example is a little bit more tricky. Let's have a look at why it is. In this one, if I start to label everything up, I'm going to get this angle, which I could call angle A, and this side, which I would call A. Now the problem is here, this length of 5, I do not know the angle that's opposite it, and I need to know that in order to work out this problem. So what I'm going to do is a little tweak on this. I'm going to remember that the angles in a triangle add up to 180, and I should be able to work out that my missing angle is 123 degrees. From now on, I'm not interested in that 22 degrees. It doesn't help me at all. So I set up my problem for this one. It's going to be 5 over sine 123 equals X over sine 35. Again, like in the previous example, I'm going to multiply both sides by sine 35 to give me 5 sine 35 over sine 123 will tell me the value of X. And when I type this into a calculator, I'm going to get my missing value, which is 4.1 centimeters. Here are 4 to have a go at yourselves. Take care. One of the questions in here will require a little bit more thought. Pause the video here to have a go at these for yourself. When you're ready to go through the answers, hit play and I'll talk you through it. Okay, in this first one, I'm going to set up the sine rule problem. So I know that 3 divided by sine 44 is equal to X over sine 27. When I type all this into my calculator and multiply both sides by sine 27, I will get the final answer. X is 2.0 centimeters to 1 decimal place. This second example, again I'm going to set up my sine rule. It's going to look like this. 7 over sine 71 equals X over sine 55. When I multiply both sides by sine 55, it's going to give me a value for X of 6.1 centimeters. This third one is the one to take care with. 28 is a red herring. I don't actually need it because the side opposite it is not given to me. So I need to work out this angle here. I'm going to use the fact that all of the angles in a triangle add up to 180 to work out that this missing angle here is actually 95 degrees. Once I've got this, I can set up my sine rule problem and I can go 5 over sine 95 is equal to x over sine 57. When I multiply both sides by 57, I'm going to get my final answer here, x equals 4.2 centimetres. The fourth example is quite tricky. Take care with this one. Whenever you have small angles inside a triangle, it can get a little bit difficult to correctly identify which side is opposite which angle. Take care when labelling. In this one, the 10 centimetre side is opposite the 21. So setting up the sine rule equation, I'm going to have 10 over sine 21 is equal to x. And x is opposite sine of the 10 degree angle. When I multiply both sides by sine of 10, I'm going to get x equals 4.8 centimetres. Well done if you got all 4 of those correct. I would recommend having a look at the sine rule missing angles video next. Thanks for listening.